Hi, my name is Kevin Goulston, and today we're going to be talking about pricing engines, a low latency solution for market data. Before we get into it, I just want to set our agenda a little bit. What we're going to be doing is talking about market data and helping understand why it becomes difficult, why there's such low latency concerns. Next, we're going to talk about a single approach to market data, specifically the pricing engines. And then we're going to lay out some of the technical considerations and talk about some of the speed tricks that are usable. However, I want to set everyone's expectations. This is not a how to build a pricing engine. You're not going to come away with code snippets or a blueprint on how to do it. This is an architectural discussion on the difficulties of market data and one of the solutions that is presented for dealing with it. A very good one, but one of the many solutions. Walking away from this video, you should have a much better understanding how to build a pricing engine, or better yet, what a pricing engine does and enabling you to build it. So great, let's talk about what market data is. Market data is defined as price or trade data for financial instruments reported by a trading venue. In other words, it's tick data. It's their trades, it's quotes, and they're being reported on a financial instrument, i.e. equities, futures, options, fixed income securities, cryptocurrencies, Bitcoin, etc. Coming from a trading venue. Any place where those instruments that we're talking about are being traded. So the question is, why is this so difficult? And the answer is because of three things, right? Scale, distribution, and complexity. Let's flesh that out a little bit more. What do we mean by that? Scale. What scale refers to is you're receiving information from a single exchange. Now, and this gets difficult because you're suddenly dealing with a lot of volumes, right? On the equity sides alone, you're dealing with something along the lines of 500,000 to 1 million updates per second at peak times. Now, that coupled with distribution, meaning that you're getting it from different sources, and each of those different sources have their own high volume problems, right? In fact, they're very much related. When you see one exchange increase in volumes, the odds are really good that the other exchanges are increasing in volumes too, because there's something happening on the market. So suddenly we're receiving 500 to 1 million updates per exchange, and we've got multiple exchanges. And adding to that is that these are in different geographic locations, and that's something we're going to talk a little bit more about. So great, let's continue down this path, let's continue fleshing this out, and let's suddenly start talking about the complexity. So the first thing that we talk about when we think of complexity is we're seeing how the data is delivered, i.e. how that the exchange publishes that data to us. And the next thing that we talk about is when do you receive your data? And that second part is actually really important. Because what's happening, or what you have to understand, is that exchanges go out of their way to be fair. Whenever you're receiving your updates, your competitors are receiving the updates at the exact same time. In fact, exchanges are known to wrap lengths of wire around to make sure that the distance between your servers and your competitor servers and the exchange's servers are the same distances, right? They're going to make sure that there's no competitive advantage whatsoever, even so far as to say the length of wire that's connecting your systems, right? And then the last thing to consider about, and this goes back to that distribution problem as well, is where are your trading engines sitting, right? Because they may not be in the same place that your market data is coming from. And that's something that you're going to have to take into account. And that's something that we're going to talk a little bit about more as we start exploring, as we continue fleshing out the complexity aspect of this. So great, let's continue talking about how market data is delivered. Right? Now, what most exchanges do is they break things down into multicast channels and they stripe it by symbol ranges. And what I mean is that all tickers, starting with A through B, are going to be happening on multicast channel 1, and all tickers going C through D are going to be in multicast channel 2. Now, for the purposes of this example, let's just assume that we have 10 multicast channels overall. Right? What this means is that if I have an algo engine, and I actually want to listen to a single ticker, let's say Alcoa, right? I want to listen to the ticker AA. I have to subscribe to multicast channel 1. And that means that I'm going to be receiving 50,000 to 100,000 ticks per second, even though I'm only interested in a single stock. And this is usually referred to as line pollution, right? Because you're polluting your system. Your algo is suddenly going to have to be able to start throwing away a whole bunch of different ticks in order to make sure that you're only receiving the Alcoa engines. Now, the same thing is true for any tickers that are in the different symbol ranges, right? So, for example, if I want to listen to DDD, the same thing, I'm going to be receiving 50,000 to 100,000 ticks per second, assuming fair distribution across multicast channels. Now, where things get a little bit more interesting is what happens if I have a third system, a system that actually wants to listen to both Alcoa and the triple Ds, right? Suddenly, I'm receiving 100,000 to 200,000 ticks per second because I want to receive two stock prices. That's a problem. And you can understand where the term line pollution comes from, right? Where you're polluting the rest of your system with things that you're not interested in simply because of the way that the exchanges are delivering it to you. Now, in addition, we need to talk about the fact that we've got multiple exchanges, and not all exchanges have the same number of multicast channels, right? In a more realistic situation, the NYSE multicast channels is actually broken down into 35 different ticker ranges. And so suddenly, if you want to subscribe to any particular symbol, you have to know which partition within those 35 you're going to end up listening to, right? So that adds a little bit more of complexity that you should be able to dynamically figure out when you're going to start and stop listening to a multicast channel. The other problem is the fact that you've got multiple venues, right? And those multiple venues, for example, NYSE versus BATS, are probably going to be trading the same ticker. And the fact that you want prices from each of these different exchanges, they have to be related somehow into a financial instrument that your system understands how to process. You're going to have to be able to differentiate the gold price, the gold ETF coming from BATS and the gold ETF coming from EDGA. Now, even on top of that, you've got multiple different exchanges within each exchange, right? So you've got exchanges that provide you rebates versus exchanges that are liquidity taking. So, for example, BATZ and BATY. And each of those guys have the same symbols. And you're going to have to be able to handle that symbology. This is historically called the problem of multiple listing. And how you deal with that becomes important later on down the road, and we'll talk a little bit more about that. I've given examples of how it's difficult to relate even the individual ticker that we're talking about, but life gets even more difficult because there's a third exchange out there, and let's say it's a future exchange. And since the example that I'm using is a gold ETF, let's say that I actually want to start receiving prices for a gold commodity. How do I relate a specific expiration to that particular ETF? And depending on my particular system, do I relate that same commodity to different tickers by different exchanges, or am I using that global multiple listing ticker? Right? So these are all problems that need to be considered as you're building out your system. Great. So another problem is the exchanges publish their ticker ranges based off of multicast channels, and your trading system subscribes to that multicast channels. Now, what we found is that multicast channels are incredibly reliable within a data center. However, that reliability drops precipitously when you start going across data centers, when you start crossing from New York to Chicago, or New York to London, or London to Chicago. Suddenly, that UDP reliability becomes a problem. You go from 99.99 down to something like 80%, right? And the problem is you don't have the option of choosing which ones are going to be dropped. It just happens randomly, and good luck to you. So one of the things that you have to be able to deal with is that you are in fact going to be subscribing to market data across different exchanges. And how you get that market data from one exchange to the other is actually quite important as well. So let's talk about some of the problems that we've dealt with market data. And these are the big ones, right? There are going to be more specific issues to different trading systems based off of how they've been architected. But these are pretty much ubiquitous to all trading systems. You've got to be able to reduce/eliminate line pollution. You need to be able to handle multiple listings by type, by exchange, and you have to be able to handle locality and deal with the problem of long lines. And how do you do that? Oh, and on top of that, because you've got your competitors to deal with, it has to be super, super fast. So the question is, how do you do all of this? And my answer to this is a pricing engine. So great, let's talk about that. What is a pricing engine? And it's very difficult for somebody to sit down and give you a dictionary definition of what it is. So instead of trying to do that, what I'm going to do is I'm going to walk through some of the examples of functionality that you'll find inside a pricing engine. And as we're doing that, we'll see a design start to emerge on how one would build a pricing engine. So great, let's jump into it. Pricing engine functionality. The first and foremost, no matter what happens, a pricing engine is going to be subscribing to a minimum of one and possibly all of the multicast channels that you are receiving from a particular exchange. And you're going to be doing some kind of transformation on the data coming in. What does that mean? All right, so the first example is a naked operation. And naked operations mean, hey, I received an update from the exchange, and I'm going to do absolutely nothing to it. I'm going to report it exactly as I received it, and I'm going to send it out. This is a pass-through. This is the easiest incarnation of what a pricing engine does. But the fact that I'm actually intercepting prices before I'm sending it to Algo means that I can suddenly start doing some interesting things on it. For example, I can start publishing confidence levels, right? I can suddenly start looking for clearly erroneous tick information. In this example, right, you can see right here between the 3251 and the 3210 or 32510, something somewhere, that was a fat finger problem, right? Somebody typed in something and they missed the period. And so suddenly, as far as my algorithm is concerned, it moved up by, back by a factor of 10 in a single tick. And then it actually came back down in the next tick, right? So a pricing engine can actually look at that and say, if something moved by a factor of 10, or it moved by some degree, however it is that you configure your system by, you can flag that as an errant tick. And that errant tick may or may not be published outside of a pricing engine, right? Your algorithms can look at an errant tick and decide to treat it differently, or in fact, you may not decide to publish this at all. Now, this is important because if you don't do this, what you suddenly find is that a lot of this protection logic is being implemented in the algorithms themselves. And then suddenly you have different protection logic being implemented in different algorithms, right? And so you have different people calculating when an errant tick becomes an errant tick. And you get a very large deviation of how these price checks are done. And it becomes difficult for developers or operations to track down why something went haywire when it did. Right. Another example of stuff that you can do with the pricing engine is you can suddenly start building baskets. So for example, let's say I want to build a basket called telecoms, right? And in my particular basket, I wanted to have AT&T, Verizon, Sprint, and RCI. And I actually want to give these guys different weights because why? That's how my traders have decided that they want to build that particular instrument. I can actually build a weighted average of this particular instrument and create a brand new instrument and create something that's never existed before that is more useful to my traders or to my users than individual tickers. And on top of that, right, I can suddenly control when things get published. If I'm just publishing out a tick every single time this basket sees one of its components tick, then I'm going to publish something like 10, 25 ticks on a per second basis. Whereas you can end up making better statements saying, I only want to see publications if the decimal moves up by a penny, or whatever rules you and the business users end up coming up with. You're going to be able to vastly reduce the data flowing through your lines when you suddenly start implementing these kinds of rules. And along with this, you can see the power of being able to configure this. When does a publication get changed? It's configurable. It's not coded in. It's in fact specific to each of the instruments that you're creating in the example of baskets. So great. Let's start talking about a pricing engine. And let's compare that to what's happening in the real world in the market. So right now in a real world market, you get a multicast channel 1 listening to Alcoa, for example, and I'm going to start receiving that 30,000 updates per second simply because I want to receive one update. Option number 2, right, is we can do that naked operation. I can have that pricing engine listening to those 30,000 operations, filtering out Alcoa or filtering out that individual ticker, and then publishing on a brand new multicast channel only that ticker. And what that means is that algo in blue, that new algorithm that shows up there, by definition, it's only going to be receiving things that are interested in it. Now, This only works if this thing is super fast, because the question suddenly becomes, is it worth it? Is it worth putting that middle layer of the pricing engine right next to where Algo 1 could be, right? And in the super fast world, the answer is a resounding yes, because the amount of work that Algo 1 is doing in order to filter out that 29,000 messages per second, only to listen to that 1,000 messages per second, vastly impacts the performance. Whereas the second Algo 1, the one in blue, only receiving interested information on it, is able to act in an immediate manner. It doesn't have to do that filtering, and therefore it's a much faster, much cleaner response. And not only that, I can define that multicast channel. It doesn't have to be based off of a single ticker. I can have as many of these multicast channels as I want, and they can go to different algos, right? And you can mix and match which tickers go into which multicast channels. These channels can be shared. These channels can be broken down by ticker. These channels can be broken down by the thing that becomes most suitable to your particular trading system. What's important in there, though, is that if an algo is receiving a price from your pricing engine, it is by definition interested in that particular price, right? So it doesn't have to worry about any of that filtering out. It is also, by definition, an actionable price. It doesn't have to be filtering out prices that may or may not be valid or invalid, or be wary of it, right? That information has already been done for you. Now, how an algo engine communicates with the pricing engine, indicating what pieces of information it's interested in, is important, and it's something we're going to talk about. But immediately you have to realize it's not part of the critical path, right? Let's say I have a pricing engine that is set up to receive prices for Apple, Microsoft. That's great, and it's publishing to my algo engine. How does that algo engine tell the pricing engine that it's interested in those things? Well, through configuration management, of course, right? That configuration, the algo engine says I'm interested in these particular tickers, and the config management says I know the pricing engine that's configured for those tickers is X, and it's going to forward on that piece of information. That doesn't mean that it's the only pricing engine that has to be communicating with that algorithm, right? An algo can be receiving prices from multiple pricing engines. And not only that, one pricing engine can actually subscribe to data from another pricing engine, right? These configuration management messages are in general called expressions of interest. And those expressions of interest are actually quite important. Let's talk about why. So we're going back to this we're going back to the concept of the fact that we've got one pricing engine data center A, and it's got its multicast channel set up for, its algo A. Now I've got a different data center B, right, in a separate location, and it's got its own multicast channels. Let's call it multicast channel 1 with algo 1. Now, let's say I want to compare prices between the same product traded on multiple exchanges. I can do that really simply because that pricing engine 2 can be a client of pricing engine 1, and it can even subscribe to the same ticker that is publishing within the data center B. Those expressions of interest, they carry with it not just the ticker that you're interested in, right? It can also carry with it the types of updates that you're interested in. It may very well be that you're only interested in trades, or you're only interested in quotes, or you're only interested in reliability info. There's no reason to pollute the rest of your lines with things that you're not interested in. So you can further filter down the pieces of information flowing across those log lines. But even more importantly, you can include location information for it, right? You can say where the source is coming from and where the destination is going. And then it can make an intelligent decision of whether or not that particular client is sitting in the same data center. If it's sitting on a remote data center, you want to publish things via TCP. If it's sitting in the same data center, you want to publish the things via UDP. Now, this is true for pretty much every single client that you have, be it a separate pricing engine or a separate trading engine. And this also takes us closer to the path of building your own consolidated market data feed. Something else to talk about is that these pricing engines can actually perform some additional logic, right? That the same way that you're building a basket, it can actually do some very basic math. You can't do too much math because then you suddenly start impacting performance, but you can do basic math. So for example, calculating the price of an ETF is in general a cash component plus plus the cost of the commodity backing it divided by 10. So that's an example of additional functionality that you can do from a pricing engine. If you want to see more about how to calculate the correlation between gold futures and ETFs, there's a web link right there in the middle of the screen. Please feel free to follow it. So great. I think that sums up the discussion of what pricing engines are in general, right? Let's try to combine all of it put together. So when we talk about a pricing engine, what are we talking about? We're talking about something that's able to handle inbound multicast channels. And it's going to configure those modules so that it knows which ticker it's going to be listening to, which multicast channel it's going to be subscribing in order to get that ticker, right? We're going to have some kind of subscription module, knowing who's interested in what ticker and what piece of financial information, what kind of updates it's listening to, it wants to listen to, where that person is publishing it from. We're going to have a group/channel definition module, right, that is going to be reading information from that subscription module and figuring out how it should be publishing this in the most efficient manner possible, right? You don't necessarily want to have each ticker having its own multicast channel. You don't necessarily want to have a multicast channel per algo. Some combination of the two usually works the best. Right? We're going to be able to do some kind of logic, right? We're going to be doing some kind of math. We're going to have to figure out if a particular update needs to be a naked operation or if a particular update is adding to a basket. And then, of course, we're going to have a publication module. And that publication module is the one taking care of establishing a new multicast channel if necessary, publishing the appropriate updates to that multicast channel, and or even publishing it over TCP or some other kind of messaging protocol in the event that you're going across multiple data centers. And of course, we need a statistics and measurement module, which is something we haven't spoken about yet, but that's coming up in the next section where we suddenly start talking about architectural overviews. So great. One of the things that's very, very important to realize is that however it is you are building your system, you have to clearly identify your critical path and ensure that any config changes, subscription changes, updates, and things of the sort aren't messing with your critical path. And in the instances that I spoke of right now, that red line is describing a critical path. And that's important for latency. If a trading engine shuts down and unsubscribes from stuff, that shouldn't affect other trading engines and suddenly slow them down because somebody is removing itself from the subscription module, right? So you need to be very careful about making sure that critical path is not impacted. And the same thing is true whenever you're going to be gathering statistics and measurements. So great. Let's talk about some of the technical challenges that you'll be facing in general, right? There's a lot. There's a lot to be said for building these low latency systems. I like to break them down into the good and bad colors. So the JUnit and the micro benchmarking is actually really good when you're developing on your dev machines or even on your dev lab. And you should never be using these numbers to predict production quality, right? You also have to assume that the behavior is going to change. And in fact, if you are seeing constant behavior in your system, something is probably wrong. It means that you're not taking into account the normal ebbs and flows of the market, i.e. higher and lower volumes because of naturally occurring phenomena in the market, right? And then, of course, you have to be able to get around gotchas like nano time resolution happening on a single core and being able to generate fine-grained microsecond and nanosecond timestamps and how you actually get that kind of stuff, right? Histograms in general are a little bit too slow and they become difficult to deal with. And something that's actually quite important is the fact that you have to have live reporting. You can't publish a statistical piece of a data file at the end of the day and assume that it's going to behave the same tomorrow. That's back to the assumptions of constant behavior. You have to have some kind of GUI that's updating on a per second basis and is going to start flashing red when things start slowing down. So whatever it is that you're doing, you need to worry about that in a very, very real way. Now, statistics calculation cannot be on the critical path because you're actually adding latency. You're doing a lot of stuff in order to calculate that statistics that is going to be impacting the latency, right? So things like capturing timestamps throughout your system, that clearly has to be on the critical path, but the calculations across those timestamps, they do not. Right? The stats are not done there. The calculations of a timestamp from the beginning, from when an update started, to the time that an update ended should be passed off on a separate thread. Only the actual obtaining of the timestamp should happen on the critical path to make it as lean as possible. Right? Now, your statistics creations and your statistic publications have to happen outside of the critical path. However, they actually have to happen in as close to real time as possible. Yes, I realize that everything that I just said are competing priorities, right? You don't want it impacting the performance, but the only way to do it is to impact the performance. That's unfortunate. And some of the quantiles that you're always going to be interested in is the 50th, 90th, and 99th. If you've done your job correctly, the 99th will be a little variable, the 50 will be rock solid. Now, the bane of market data systems in general are garbage collection pauses, right? And what you want to do with those garbage collection pauses is to just flat out get rid of them. And there's three ways to do it, right? There's the standard Java approach, which is don't worry about it and let the JDK handle your garbage collection. This is a bad approach. One of the reasons it's a bad approach is because as things get closer and closer to very well-known peaks in the market, such as market open, as market close, volumes start to increase. And that means more and more and more garbage gets collected as you get closer and closer and closer to the time. And it's not uncommon for that threshold of when the garbage collection suddenly kicks in to coincide almost exactly with the market open or almost exactly with the market close, in which case your market data system suddenly stops working because you're having a massive garbage collection. Right? Now, the third approach is the zero garbage approach, where you're not going to be generating any garbage whatsoever. This is really hard to build and really hard to maintain. This is something that I built in the past, and it's almost too painful in order for the rewards that you reap. Instead, I like to take a certain approach somewhere down the middle, where you have what I call a low garbage approach, right? You're taking care of the most egregious issues. You're not doing string manipulations in the critical path. You're not generating new strings. You're not generating new quotes. You're not allocating memory every single time you receive an update from market data, and you're not allocating memory every time you want to publish a piece of information. Finding and killing those most egregious issues, like 90% of it, will actually get you to where you want to be. And how do you do that? Right? I mentioned a few of the cases that we talked about. I mentioned a few of the cases, like not doing string manipulations and things of the sort. But there's a more standardized approach. And what I'm talking about specifically is object caching and object pooling. I'm not going to explain what caching is. I assume if you're watching this video, you already know it. But what you want to make sure that you're doing is caching instrument and config data instead of polling that every single time or regenerating that config data based off of some kind of updated timestamp, which is something I've seen a lot of people do because they want to keep track of the last price that they've seen. So you need to be able to cache that and then publish that out in an intelligent manner. And then object pooling, for example. You're never going to be creating any of your quote updates, your trade updates, things of the sort. Those quotes and trade updates have already been created. You're going to have to pre-allocate a very large number of it and reuse that memory, right? But that's one of the most egregious pieces of garbage collection that you're going to find inside market data systems. And because that is a configurable number, you can fine-tune the appropriate amount of memory possible, as well as how much volume you're going to see in those ebbs and flows. Clearly, you're going to have to worry about the garbage collection engine that you're using, as well as make sure that you warm up your JVM. There are a lot of instances where I've seen people suddenly turn on their systems and send in a million updates from the responses that we saw yesterday at the market close. And that sounds like it would work, but it is deficient because it may not have hit all of the symbol ranges. A lot of your symbol ranges may have stopped ticking for whatever reason, halts from the SEC, just low volume tickers, things of the sort. So whenever you're warming up your JVM, you actually have to put a lot of thought in to make sure that you're hitting all of the edge cases and making sure that each of those edge cases is getting 100,000, several 100,000 times in order to kick in and make sure it's not de-optimized by the JIT. Also, your buffer allocation. So something that is very important when you're trying to filter pieces of information out. What people normally end up doing is you get a piece of data from a multicast channel, and then you will deserialize all of that into what's called, typically a quote update or something of the sort. And then you compare your ticker and you say, no, I'm not interested in this, and you throw it away. Well, instead, you can actually inspect your backend buffer directly and look at the field that you're interested in, specifically in this example, ticker, and then be able to say, yeah, go ahead and deserialize it because this is a piece of information that I'm interested in versus the ones that you're not. And I think that brings us to our to the conclusion of this particular video. If you have any questions, please feel free to add a comment down there or pop me off an email, which was presented at the beginning of this presentation. Happy coding, everyone.